Okay, dual credit, let's look at what we're going to do with your data and learn how to do our calculations. So one of the first things we need to do is we need to take our data from Vernier and we need to do some stuff with it. So first things up, we're going to come up here to your pH and you're going to click on the three dots. And I want to say add calculated column. And we're going to call this first calculated column first derivative. And then I'm going to go to insert expression. And it's super easy. I'm just going to click on first derivative. I'm going to apply. Okay. Now I can't see what's happened yet, but I've got numbers in that column and that's good. So then I go back to the pH and I say add calculated column. And I'm going to do the second derivative. Once I have this, I go insert expression and I say second derivative, apply. Now, to see what I actually have, I'm going to click over here on the y-axis where it says pH. And I'm going to click off the pH because it's just going to make it messy. And I want to see the second and first derivative. So I'm just going to click those bars over. And now, if I click on the magnifying glass on the bottom left side, then now I can see. What I'm interested in is these spikes right here. Okay? These spikes here tell me where the equivalence point is for my reaction. So, how do we use this? Well, what I'm going to do is, first off, I've got to deal with the KHP. So on your next lab, I'm actually going to make you make your own KHP solution. And what we'll do is you'll have to calculate how much solid KHP you'll need in order to get a certain amount of sodium hydroxide to react. And so for this problem here, I've got 0.20 molar sodium hydroxide. I want KHP to react completely with 25 milliliters of it. And so I'm going to convert that over. It's a 1-to-1 ratio between KHP and sodium hydroxide. And KHP weighs 204. So again, on your next lab, you will be calculating that. But for this lab, I set it up for you already. So my first step is to figure out what the molarity of the KHP is. And so when I was doing your lab and setting it up, I weighed out 5.10 grams of KHP, and that ended up being 0.025 molar KHP when I do the calculations. Then, step 2, I have the reaction written out to you, and this is why we can do it like this. It's a 1-to-1 ratio between your sodium hydroxide and your KHP. And so, with that in mind, I take my molarity of my KHP that I have, and I'm going to say it's a 1-to-1 between those two. And then I'm going to convert to molarity by using my liters of my sodium hydroxide. Now I got that from my derivative right here on the graph. Because when I clicked it here, it weighed 29.50 milliliters. I divide that by 1,000 and I get 0.0295 liters sodium hydroxide. It happens to be that sodium hydroxide is not quite 0.1. It comes up 0.847 as being the actual molarity. Okay, so that's what we got for our KHP. So can't say it's 0.1, it's actually 0.8. So once I have that done, now I can go and work with my calculations for everything else. So again, I need my derivative from my reaction. And when I did this, I found out that my acetic acid, it was 11.0 milliliters. So I'm going to do M1V1 equals M2V2, or MAVA equals MBVB, okay? I'm solving for MA. My volume of my acid was the 50 plus the 10 of the acetic acid, so I have a total volume of 60 milliliters. Here is where I'm going to put in, sorry, that's actually volume. I'm going to put in the volume that came off the graph, which is 11, times the molarity that I just solved for with the KHP. When I do that, then I get my molarity of the acetic acid. So that's how you're solving for your problems to get your molarities of your unknown acids. And that's why you need to be able to calculate using your graphs. And this is just some more examples of some sample data so you can see some more examples on how to calculate that. I hope this helps, and live long and prosper.